Hello, everyone. So yeah, okay. Then I'm going to share my screen. Let me wait a little bit. Oops, this is not the one. Here.
Beautiful home office, by the way, Susana.
Ah, thank you. Well, I try to make it feel cozy. Okay, I don't know why I can. You're still not seeing my screen, right? Or are you seeing something? No.
I can see you. I can't see your screen.
You can't. Okay. Yeah, it says that it has a problem. I don't know why. Of course, there is always something. Okay. Okay. It's not letting me to share my screen. I'm going to try to connect again, okay? Oh, okay, wait. Here is a problem. Wanted is in this other one. Yes. Later. Right. Okay, I guess not. Can you see something now?
Yes, we can see you.
But
Yep.
you can see the screen now.
On the screen.
Yes,
Yeah.
the query language example.
Okay. So hello, everyone. I am Susana. I've been working with Gina for the past month and 2 weeks, or maybe a month and a half, something like that. And yeah, I'm happy to be here. Thank you for joining. And I hope I can explain to you this a little bit better. So just to like an overview what we're going to do now. So I'm going to go through an extension of the example of the Hello World. So in the Hello World, we had the fashion data set, and then we were showing all the categories. So we were seeing all the examples we had sorted by category, right? So what I'm going to do now is use something called QueryLang, which is something we introduced in Jina. I think it was Jina 0.5, if I don't misremember. And with that, what we can do is to filter our requests, so our results. So for example, why would I want to use this? So one example could be in the Hello World. What if I don't want to see all the categories? What if I just want to see, let's say, only the sneakers, the shoes, only the boots, only the bags, the dresses, for example. So right now in the example as we have it in the Hello World, that's not possible. So we're gonna see how we can do this using the QueryLang. So yes, like it says here in the slide, in the Hello World example, we have 10 categories. I think there are bags and shoes and so on. And we're going to create a document for each of them so we can then query. And so it's easier for us to access. Okay. So yes, the plan how to do this is going to be with the query language. So just to let you know, I'm going to show you the code, but I also had some slides to make it, because I feel like sometimes maybe I don't explain it very well. So I also made the slides, so maybe that's easier for you. So I'm going to show you the code and to go through the code together, but you will also have the slides if that's easier for you. And I have this slide here that it shows us like a little bit of the plan of what we're going to do. So it says we're going to download the data and the labels. In the Hello World, in the first example, we were only downloading the data and not the labels because we didn't needed them for that example. So in this case, we're going to modify that and get also the labels so they are matched together with the vector of the data. Then we're going to get our flow index, and then we're going to use the QueryLang. So yeah, let's see. So like I said, I'm going to have in the slides also some screenshots of the example, but now I'm going to switch this to show you the code. This is not the one. It is this one. Yeah, you can see now the code, right?
Yes.
Yeah.
There.
Okay. Yeah. So what is going on here? Let's see. So as you can see here in the main, we have our target where we are downloading the data, right? That is the first thing we need to do. Like I said, in the previous example, we had only these two. So we had the index and the query data, and now we have the labels. So we're going to put everything in this target. Here is going to this function that is going to download all the data. And now we're going to go to the indexing part. So in the index part, we're going to load our flow index YAML file. So we're gonna go to here. Okay. So you can see, if you've seen, I guess you've already seen the Hello World example. This is a bit different in the sense that it has here all the categories. So this is what I said at the beginning, that we're going to create 10 documents, one per category. So there are 10 categories, we're going to create 10 documents. So then we have here our pods, and we are going to make a YAML file for every category. So we have, I know it sounds a lot of YAML files and I'm repeating the same word, but we have a YAML file for the index, and then we have more YAML files for our categories that we're going to have here in this folder called index. So then we go to this one, and then here we can see that we have this part here. This is similar as what you've seen before in other examples, nothing new here. But in this part, we are using now a filter query language. So here I am saying that for this particular YAML file, which is the boot one, I'm going to use this tag, this label. For the bag, I'm going to use, of course, the bag label, and for the code and so on. And I'm going to do that for every category, for all of them. So then I'm going to have them separate them, you know? So if we go back to our index, here we're just creating one for each of them. And then here we're just joining them all together. If we go back again to our flow. So now that we had these YAML files already here, now we're actually going to do the indexing. So I go to here, index generated, this function here. And what is it happening here? So sometimes, I don't know which examples have you used, but sometimes you are using just the index. Sometimes you're using the index underscore files or these other functions that we have. So here I am using the index one. So because I am using this one instead of index files, for example, I have to make this proto document by myself. So this is all that is going on here. It seems like a lot of stuff, but actually what I'm doing here is that from the target, you remember that we got our data, or the labels and the data, and we put them into the target. So this is actually just integers, right? So I have them here, and the labels as they are, they're just integers. But because it's easier for me as a human to understand what is actually a number 2, so in this case a pullover, so then I just make this little function that is going to just map the integer to the category. But that's just because it's easier, right, for me to like kind of debug. But that's all. Yeah. So this is what I'm doing here. No, sorry. This is here. I'm getting just the label, the integer, and then here I am actually mapping into a string, and that string is what I am putting into the label, which is going to then be checked with this label here. If I wouldn't have done that, to map it to a string, then I would have needed to use here, instead of a bag, I would have needed to use a number that is corresponding to that, That's why I use the string, because I feel it's just easier to debug. So this here, where it says the update, is where I am actually updating the label of each category, because otherwise I wouldn't know. So when you do that in your work directory, which is workspace here, usually you will, in the other example, in the hello world, you wouldn't have all of this. I think you will have one, I don't remember. But here I have 10 of them for each category, and each one of them will have all this information inside of this one. So they will be separated, and because they are separated, it's easier in the query time. I know that there are 10 categories, so I go through them. So this is the index time, and in the query time, it is very similar. If you look at it, how is it right now in the code? I think it is exactly like this. So right now, if you run it as it is, you will see all the categories also. You will see all the dresses, all the shirts, everything. So, I mean, the point of this is to actually query, right, per category. So if you want, for example, let's say you want to get only the sneakers, how would you do that? One way to do that I can think of is like here, for example. Yeah. Here you will, okay, first of all, I'm going to try to do it now, which that means that there's always a problem that when you want to show something to the world, everything collapses. So let's see what happens. So, okay, let's try to to filter only by, the sneakers. So I'm going to make it a category, right? So I'm going to say the category is going to be, so this label. So I'm going to get the label from the target, and then I'm going to map it to a string, so I can know what it is. Okay, so in theory, this category is going to have now the value of dress, or the value of bag, or the value of sneaker, or whatever, right? So if I want to get the sneakers, I'm going to say if the category is sneakers. I think it's sneakers or sneaker. I don't remember. Let's see. So let's run this and see what happens. So in theory, if I run it now, instead of seeing all the categories, I'm going to have only the sneakers, let's say. So okay. Yeah, it's not the sneakers, it's the sneaker. It always happens. There's always something. So let's try again. Yeah, you can see this, right? Or you can still see the code.
Yeah, I can see the output scrolling along the bottom and the code at the top in your editor.
So you don't see the results. Okay, no, this is. Yeah, because I am on the other. How can I switch to this one? Here. You can see it now, right? You can see the results now.
Yep.
Okay. So yeah. So now you can see the results, and you only see the sneakers. So it worked. And that's how you would do for every category. There's no need for me to show you all the bags and all the dresses. which are so cool. But yeah, so this is how it works. So what happened here, it's just that now because we had I'm not sharing again. This one. Yeah. So yeah, what happened here is that because we have now our categories here in this part, it's easier then to look for them on the query time, because they are separated then, and then we can filter with their category when we do the updates of the label here. So I don't know, then you could probably maybe get the category from the input from the user in the terminal, or I don't know, it will depend on what do you want to do. Also, I'm going to go again to here, which is, where is it? Here, you can see the presentation again, right? The slides.
Yep.
Okay, yeah, okay, so like I said, I feel like maybe sometimes I explain things very strange. So I also have screenshots of everything that I talked about here. So maybe it's easier for you to say, and also you can always ask me, you know. So in Slack, maybe it's easier for us to understand. But here there are the slides, and what I wanted to show you also is that here I am using the filter, the filter QL, but you can also use other things, for example, sort or slice, and you can see all the details here. There is a blog post that handmade where it's very well explained how this query language works and what do they all of them do. Yeah, so you can check them there. Yeah, let me see, there's something else here. I just show you also the example, and here are the results. I think I made a comparison. I can never pronounce that word, but you know, like when you see two things. So there is the hello word here on the right, where you have all the categories, and in the left side you can see that I query by dress, I think in this case. So this is how they both differentiate from each other. And yeah, I think that's it. Yeah. So that was it. I hope I could explain this to you guys. I hope this worked a little bit for you. I think we're going to have a presentation now with Max. So I don't know how that works. If you have questions, maybe not. But if you have questions, you can ask me, or we'll wait for Max. I don't know how this works, but yeah. Thank you for listening, and always ping me if you need anything.
Invitation from AngelHack, they might have it.
Hey, everybody. We are having some technical issues with Max's internet at the moment, unfortunately.
No, but I'm there. No
Oh,
worries.
you're here.
Yeah.
Hallelujah. It is so good to
Yeah.
see your face.
All good. Yes. So I guess we skip or put the questions to the end of the webinar, and then I go ahead, and when questions to Susanna's part came up, we answer them at the end, right?
Sounds good.
Perfect. Then let me share my screen. You should see my screen now. Did that work?
Yeah, we see it. We see it.
That was easy. So yeah, welcome to the lyrics example. Let me just hope you can see everything. There's can I hide these things? No, it's great. Okay, so I will talk about the multi-res lyric search in the examples dictionary of our Jina repositories. And first, I will talk about what's the target of this presentation and make a short live demo. Then I will explain the data structure behind the live demo, show how searching works if you have chunks of documents and also chunks of queries. And finally, I might go again into the demo and play a little bit more around with it, and also show some code and go through the code. So the target of this demo, in principle, is to explain a recursive data structure. So in a lot of Jina examples, you usually have a data structure where the documents are not further chunked down into matches. But here we really want to have somehow text, which we chunk in sentences and then search on a sentence level, but still in the end get texts back. And yeah, I will explain the concept of chunks and also explain how you in the end can get a scoring and can also write your own scoring or change the scoring and how you can deal with this. So first of all, let's have a live demo. What I do here is now I have two terminal windows open as it's suggested in the to do it in the tutorial. And one is in the multi-res lyrics static folder. And there I just start somehow Python HTTP server, which in the end just gives me a front end where I can play around. And the second one is in the multi-res lyrics search folder. And there I start the search. I have indexed already 1,000 lyrics beforehand, so that that takes a little bit of time, and that's why I don't want to do it live. But at least I can start the search live. So here it comes. It loads, and now it says ready to use. Let's go to the web interface. I reload it, so that's really reloaded from the interface. And now I have some secret already prepared sentences. Just yeah, it's always a demo. You always prepare stuff, right? So let's query for this. Here you see fetching results. The first time it takes a little bit of time because the backend needs to warm up, needs to load the model, and now results turn up. So what do I search for? The first thing is Brotherhood of Men. Be aware this is written wrong. Usually it's written with an A in the actual lyric I was searching for, which is What's Up. For I think 4 Non-Blondes is a band. And so I know there was something like wake up in the morning. I already remembered this was some of the 2 sentences I remembered from this lyric, and now I see okay. And so I wake up in the morning. So there's something missing. The ad is in apparently the text, but I still got this as a first match. So even though I did not put the lyric exactly as it is, I still get the right lyric at the first place. What I can further do here is I can say, okay, please show me show me only the matches for parts of the for the individual sentences I query for. So either Brotherhood of Men, or I can also say, please show me only results for wake up in the morning. And here we already say, oh, see, for wake up in the morning, there are less at the top results, way fewer. And the reason for that is Brotherhood is something which has semantically quite a meaning. And that's why it's easier to find something close to Brotherhood. For example, faith might be something which, and allegiance, something which has to do with Brotherhood, or you righteous ones, brotherhoods are sometimes righteous. So you see, it's quite easy to get a concept around the brotherhood better than wake up in the morning. Okay, whenever you have the morning somehow, or wake up in the text, it might also come up, but the brotherhood has a much stronger semantic meaning. So it's easier for the model in the back to grasp the meaning. And that's some of the examples. You can, what should happen here, and you can search for multiple sentences, and they are somehow all individually matched. So how does the data structure behind this whole example look like? Well, let's take a completely different song, What is Love, from I think Jim Carrey sang it, but someone else, it's originally from someone else, but Jim Carrey somehow also had the version of it. And so this is the song. And then we chunk down the song into individual sentences and save the sentences in our database. And sentences, the first one is What is Love? The second one is Baby Don't Hurt Me. The third one is, again, Don't Hurt Me. So the next one would be No More. And so you have like each sentence is indexed. And that's what we put in our database. And doing a search, I know, there was a song about love and something hurt me came in the song. I could query for this. And then this is also chunked down in song about love and hurt me. And now we want to search. And what actually happening, the embeddings and all the machine learning magic happens on the lower level. So the upper level, these are somehow What is Love is a document, and Song About Love and Hurt Me is also a document. The lower level are also somehow documents, but these are chunks of the upper ones. And all the machine learning magic happens on the chunk level, so on the lower level. That means when we search, the score is also first somehow calculated on the lower level. And the score in this case is a distance. Somehow these sentences are all embedded in a high-dimensional space. And so we measure the distance. And if the distance is small, the things are closer to each other. And here you see, okay, Song About Love is quite somehow is close to What is Love, but might be a higher distance than Hurt Me from Don't Hurt Me, even though don't is somehow reverting the meaning of hurt me, but still from a text, it might be quite close. And baby don't hurt me is a little bit farther away from hurt me because there's even another word in there, which might make the distance farther away. And now we somehow, in the first step, what the algorithm does, it chunks down my question in individual sentences, then scores each of the sentences against all the sentences we have indexed, get a score for each of them, and then it needs to bubble up the score somehow, because in the end, we want to have, for whatever I type in, I want to get one lyric back. So we somehow need to get all the scores I collect down here, bubble up to get scores for the actual songs. And what we do here, which might be kind of stupid, but it's an easy approach for somehow explaining what happens, we just take the minimum score of all the chunks that we have for a song and all the matches that we have to what we searched for, and just take the minimum score as a match between what I searched for and all the document, some of the document in our data store. And here it could be much more intelligent to someone say, okay, if 3 sentences of a song match, the song gets a higher score than if just 1 sentence match really good. And so this is really a dump score. And that's also when you play around with the lyrics example is why it's not working that good, because we choose a really, really simple ranker. Yeah, somehow a combination of the scores might work out much better. And just again, somehow getting the matching sentence, what happens? So we start from here, we go into the chunk off direction. Somehow we start from the song, from the whole thing I typed in, go chunk them, and then we go to the match direction. And afterwards we say, okay, the parent lyric that we get back is a match of the original query I had. That's some of the data structure. So if you think of this as a graph, you can see this is the root node. The song about love hurt me is a root node. It has chunks. These chunks have matches. And the root node also, in the end, have a match, which is the whole lyric. And this data structure evolves over time. So in the beginning, it's somehow when we start searching, it's just somehow the chunk off. Afterwards, the matches are added to these chunks. And in the end, this song somehow is added as a match to the song about love. And this is something in Jina which happens quite often, that when you work with chunks and not just somehow matches at the top level, that the data structure evolves during the flow of the query. Because you usually search at the lower level and then somehow want to aggregate these scores to a higher level. And this means you change the data structure. Yes, that's somehow all about the data structure. And now I want to go a little bit into the code. So where do things happen? In the index, we have here multiple things, and I want to talk about these things somehow a little bit because I think it's nice to explain them. So what does the crafter do? Or I hope you all have seen such a file already. If not, these are usually the flow files. We have 2 of them. One is for describing how to do the index thing part, and the second one is to describe how to do the query part. Describing the index part, first we have a crafter. When you want to know what this crafter does, well, use this. Here's the file described. Go to pods craft. Oh, this is a synthesizer, and says, okay, min length sentence length is 6. This means whatever I get in the when I give lyrics to the index of the indexing flow of Jina, it splits the lyrics down in sentence. Splitting happens here by a dot, by exclamation mark, question mark, and a lot of other different typical end of sentence symbols. Yes, and it only accepts sentences with a minimal length of 6. So when we just have in a sentence a lot of oh, exclamation mark, oh, exclamation mark, oh, exclamation mark, it might be hard to search for them or be really somehow ambiguous. So we say, okay, at least 6 characters should be there for a sentence. The next thing that we do is we encode. So here you go to the pods/encode YAML. You can look into this. This is here. And here we say, okay, we want to use a transformer torch encoder, which is a somewhat pre-trained model, which we just use to encode sentences. And there we use the Dilbert base case model. You could choose also other models if you want to have another model which somehow has the same API as this. You can choose others. If you go to the PyTorch documentation and look for transformer torch, or I think it's transformer, or just search for this Dilbert base case, you will find a lot of other models which you can play around and check if they perform better. But here we decided for this one. And this is somehow all that happens here. Encoding means for each sentence, a vector in a high-dimensional space is calculated. Then afterwards, we chunk. We have two things. We do something for the chunks, and we do something for the documents. And for the chunks, let's go to there a little bit more happens. Let's ignore the lower part for now and just look at the upper part. What happens here? With a compound indexer, which means, okay, we do two things and we do them sequentially. First the one thing, then the other thing. And the first thing is we index somehow with a NumPy indexer, which just indexes vectors. And this indexes the embeddings. And then we have a binary PB indexer, and this indexes not the embeddings, but all the metadata that is there for Lyric. So in our Lyric search, I think there is not much metadata indexed. Might be I think the whole text is indexed, but nothing else somehow. Yes, and then down here, we say during an index request, we somehow use the same chunk.yml also for the querying part. But during index request, nothing special happens. So this just says, okay, uses standard drivers and don't do anything special. For the query part, I will come back a little bit later, what happens there. So that was the chunk.yaml. And now we have the doc.yaml. Let's go here. What happens here? Okay, for the full document, we somehow just, this is how we save a full document. And in the end, it says, okay, just save it. All the information you have about the document, just write into a database. And later on, whenever a document somehow is fetched, you can also get it back. So also here, nothing special happens. And finally, we have the join all, which is something like in the beginning, we always have the gateway pod, which is somewhat the default pod. And finally, we have a join all pod, which just says because the chunk, this part is parallel to the doc IDX, because to index the doc, we don't need the chunks, so they can run in parallel. And that's why in the end, we need to somehow get the two things back together. That's all that happens during the index. And when we now want to run a query, this is pretty much or similar. The first thing is we also segment it with a crafter, which is the very same crafter, which synthesizes things. So nothing new happens here. And yeah. One thing that I should mention when I say nothing more happens here. So this sentences and creates chunks. So if we go back to the slides, it actually directly creates us the chunks from the original document. So we get really chunks back. Then we have the encode, which also is the very same encode we had before. Also, again, I mean, we want to use the same model for encoding in our database and our actual query, because if we would use another model, that wouldn't match. That would be a complete different vector space, and there would be no point in somehow doing this together. So we use the very same model. Nothing special here. And now we have the chunk IDX, and this is somehow, again, the same pod as in the index. But this time, let's go into the chunk. As a driver, we don't use this driver, but we use this driver. And what this driver in the end says, this is the vector search. So this is the one that for our query search chunks should get back our actual sentences. So this is this part. When we want to calculate the distance, this is what happens here in the vector search driver. This calculates all the distances. And what this says here is granularity range 1, 1. So start from our chunks at level 1 and start from our adjacency 1, which means somehow this here is our original query. And somehow we don't want to go along matches, but we want to go along chunks. We are on the chunk level here. And from these chunks, we want to go along the adjacency dimension and want to get other chunks in our index and get matches somehow. So the chunks on the right-hand side, the what is love, baby don't hurt me, and don't hurt me, are matches for the chunks on the left-hand side. Yes, and what is, sorry for it's a short, yeah, need a short think about this, but this is exactly what I say. So this indexer somehow builds the matches for our question chunks. And now what does this thing do? This one gets the metadata of the chunks, and it says get it from granularity range 1 and adjacency range 1, which means get it somehow, get this metadata from granularity range 1 means go down the chunks, and then adjacency means go along the matches. So get the metadata for all of the matches. This is what happened in the Kiwi search driver. And finally, we have a ranker. And here I already said the ranker is super easy. It is a min ranker. And this min ranker, together with this chunk to doc rank driver, just does what I said before, taking the min score of all the chunks of the document that we have indexed and bubble up this score for this document and append this document as a match to our query. This is exactly what happens here in the ranker. And finally, we get the metadata of the document, of the whole document, which means like getting the full text back. That's somehow the whole example. If you want, we can also have another try at this one. So watch me explode is a typical line of TNT from AC/DC. And here you see already what happens when I said, okay, we have the min ranker. This is really squishy. When I remove the dot, it's still the same. But when I change a little bit here, then I get completely different sentences back, because there might be, due to this encoding closer to this sentence, it might be if I now add another line of, oh, I don't know the song text of TNT, but wait, I can get the song text, explode. Here's the song text. Dot, why is it not here? Ooh, it's a bit squishy. Oh, I'm sorry. That shouldn't have happened. Should get back the same results. Live demos are never good, I can tell you. Never do live demos. Let's try to hell. Yeah, and here it's from highway to hell. You would expect that is at the first place, but you have also other sentences with to hell, so at least hell is mentioned. But I hope that highway to hell would come back at the first place. But apparently there are a lot of other songs with hell. Yes. I think that's it for this demo. If you have any questions, now shoot, and then we can answer them. Or also, if you have any questions somehow during the afternoon, I'm here also the next 2 hours as a mentor. You can somehow, if you want to play around first with the lyric search, and then you find, oh, I didn't got this detail, just ping me the next 2 hours, or I'm also back in the afternoon. So if there are no questions, I guess then that's it. And I'm happy to see your questions then later.
Yeah, same for me. If you want to answer, well, also if you want to answer something, that's nice. But if you want to ask me something, that's also cool. I'm going to. So I don't have any more mentor hours, but I'm always in Slack anyway. So anyway, you can always ping me, and yeah, I'll try to help you. And yeah, good. Thank you for joining.
Likewise, we're all here for you all the time. Ping us with questions, comments, feedback, compliments even if you like.
Yes, I have seen the Gina teams so enthusiastic about answering questions. I have been seeing them available on Slack and helping our attendees a lot. So thank you for the team for your time, sharing with us lots of useful skill and knowledge. I saw the participants say thank you to you guys a lot. And we will hang in for a few minutes for any questions we have from the attendees. Right after this webinar, we will also have a mentoring session. So if you like to have one-on-one conversation with the mentors, you're welcome to join. So we got one question from Rai about the mentoring hour call link. So I just pasted the link there for you guys to join in the next 13 minutes. All right, if we don't have any other questions, then we will see you in the next activity, which will be the mentoring hour call happening at 3 p.m. Central Summer European Summer Time. See you guys in the next mentoring call.